Hello friends, welcome back to STM tutorials. Myself Ajinkya, and we are here to learn more about STM controller. So let's begin. So in this video, we will be seeing how to display on GLCD. So in our last video, we displayed numbers. Today we will see how to display an image on the LCD. So let's begin. First, we will look into our code. So we have covered how to display numbers on the GLCD. Now we will see how to display an image. So first thing we will see is the clear LCD function. So as we know, we have two sections in the GLCD. So var1 and var2, these two variables have been declared. So var1 will be incremented to columns and var2 will be incremented to page. So we have total 8 pages and 64 columns in each section of the GLCD. First we have declared the column address to 0 and the page address to 0. Then we have given the command to set the column and page. Starting from the 0th column, we will be writing 0 as 0 data, meaning we will clear all the data in the column. So 0 is the data, 1 means command, and this one means display section 1. So after clearing all the 64 columns in the display section 1, we will go for the display section 2. So again, we have to set the page address to 0 and column address to 0. So we have given the page and column set commands. Now we have run the for loop for 64 times from column number 64 to 128. We have set the LCD variable 0. This one is for command and 2 is for display to section. So this for loop will run for 64 times and this for loop will run for 64 times. This for loop will clear the display 1 section and this for loop will clear the display 2 section. After clearing page 1 address in both the sections, we will go for page 2 section. So incrementing page 2. To increment page address, we have used variable var2 and it is added into the page address. So thus incrementing the page address. Now we will see LCD function once more. Here we are making the read write pin as 0. So selecting the write functionality. So what does this mean? Means ANDing GPIO ODR, this is output direction register, and with this data. So what does this mean? So we will see. So read write pin is connected to PA9. As you can see here, read write pin is connected to PA9. So we have to write 0 on the PA9 pin. So what we are doing is we are setting all the bits to 1 except B9, which is directly connected to PA9 pin. All the bits are set to 1 except B9 and it is ANDed with the data. So all the bits except B9 will be unchanged and B9 bit will be set to 0. If we count from B31 to B0, the data comes as 1111 constitute F, and likewise, so we get the data as FFFF, FDFF. So as you can see, FFFF, FDFF. This is how we set the PA9 pin to 0. That is read write pin to 0. Command and data select pin, which is A0, is connected to PA10. Now if you want to set it to 0, we will have to use AND operation, and if you want to set it to 1, we have to use OR operation. So we will see. Command and data select pin is connected to PA10. If we want to set it to 0, we use AND operation, and if we want to set it to 1, we use OR operation. While using AND operation, that is when we want to set the pin to 0, we set all the bits except that particular bit to 1. And when using OR operation, we set that particular bit to 1 and all other bits to 0. So we get FFFF, FBFF, and for OR operation we get 400. So this will set P18 pin to 1, and using AND operation P18 pin will be set to 0. We have used HAL function to set and reset the pin. Same goes for PA7 pin. First we clear using AND operation and then we set to data. And using OR operation we first set the enable pin to high, and using AND operation we reset the pin to low. So if you see, when we want to clear the data pins, we use AND operation and we make all the bits that we want to reset to 0. And when we want to set the data, we will use 00. So when we use 0, 0 and 0 makes 0, 0 or 0 makes 0, 0 or 1 makes 1, 1 or 1 makes 1. So that's why we have set 00 here. Now for the enable pin, first we set it to 1, we PA8 pin to 1. So first we make it 1, then we make it 0. Here we use OR operation and here we use AND operation. To reset we use AND, and to set we use OR operation. Now we will see how to make an image. First download an image. First download an image in the PNG format. Open it in Paint. Click on Resize. Click on Pixel. Click on Maintain Aspect Ratio. Set the horizontal pixels to 128 and vertical pixels to 64 to our GLCD resolutions. Click on OK. Now go into File. Click on Save As. Here you have to select monochrome bitmap image. Now I have already saved the bitmap image. Now what you have to do is you have to open this LCD assistant exe file. Go into File. Click on Load Image. Click on your monochrome image, that is BMP. Click on Open. Here you can see the width is 128 and the height is 64. And then save output. So here you can save the output in TXT format. I have already done that. So now we will look into our text format. So what will you get is you will get hex opcode for the butterfly image. You can do it for any other image. Copy this data and paste it into your program. So I have already done that. Here one thing I want to show you is when we don't use the const keyword and we build the program. So all these 128 by 64 data will get stored into your RAM, and this will automatically consume a large space into your RAM, which we don't want. In the right hand corner you can see that the RAM size usage is 25.47, that is used is 2.55 KB and free is 7.45 KB. This we want to consume less RAM, so we use const keyword. What does this const keyword adds? The usage is 25.47 before using the const keyword. Now what happens after using the const keyword? So you can see that the RAM usage reduces to 15.47. So why does this happen? So whenever you use const keyword, whatever the data is written into your program memory, not into your data memory. But what is disadvantage of using const keyword? The RAM access is faster than the program memory access. So the data read and write cycles take more time than from RAM. So of course your program gets slower, your time optimization gets slower, but it increases your code size optimization. Now to display the butterfly image on the LCD, we have written this small function that full LCD, and we have given the base address for the butterfly image. So this function is similar to clear LCD. So instead of giving the data at 0, we have provided the address for the butterfly image, and we have incremented the column pointer. After displaying on the display section 1, we will display the on the display section 2. So total 128 columns are written first for page 0. After that we will go for page 2. After that we will go for page 3, 4, 5, 6 and 7. So we have total 8 pages. That's why we have compared with less than 8. Not equals to 8, we have compared with less than 8. Because in our digital programming, the counting starts from 0, not from 1. So now we will build our code. We have 0 errors, 0 warnings. We will load this code into our controller. Select the hex file and load into your controller. So first digits are displayed, then the butterfly image is displayed, then we clear the LCD, and then we again display the digits, and the loop goes on. So in while 1, you can see that after displaying all the digits up to here, we have called full LCD function to display the butterfly image. We have given the base address for this butterfly image data, and after some delay we have cleared the LCD. If you enjoy this video, click on like, share and subscribe, and thanks for watching the video. We will see you in the next video.